Once upon a time, there was a village named Sitagar. Sohan was one of the most curious boy in this village. Once he was very interested to learn about shadows. He approached his mother and said, Ma, when we stand under the sun, we can see shadows. Are the shadows of a particular thing or person of the same length? I have never observed shadows closely. I think you should ask your school teacher. The next day, Sohan went to his school and confronted his class teacher with the same question. If you're really interested, come tomorrow with a long, straight stick and measuring tape. Sohan thought that the teacher wanted to punish him. Still, he went to the school with the stick and the measuring tape the next morning. Oh, you have brought the stick and the tape. Fix it in the ground. Can you see the shadow? Yes, I can. The teacher asked him to measure the length of the shadow with the tape and note it down. It's 5 meters. Now go to your class, measure the length of the shadow once again during midday and after that in the afternoon. Sohan did so. He found that the length of the shadow was 2.1 meter during midday and was 1.5 meter when measured late in the afternoon. He also measured the length of the stick. It was nearly 2 meters. He showed this data to his teacher, who smiled and said, Now, do you see that the shadow of the same object is different? This is due to the different positions of the light source, that is, the sun. Now that your doubt is solved, I have a question for you. Look at this diagram. Can you find the angle subtended by the sun at the shadow? Sir, may I go today? I'll solve this afterward. A clever boy, isn't he? How smartly he refused to solve the question. Hello and welcome to Notebook. Friends, we have already talked about various concepts of trigonometry in its introductory chapter. Now it's time for its applications. So let's understand few important terms through an example. Ria is 1.2 meters tall. She spots a balloon moving with the wind in a horizontal line at a certain height. Students, as Ria is looking at the balloon, we try to draw an imaginary line which goes from Ria's eyes to the balloon. Now, students, this line is called the line of sight. So, students, I hope the meaning of the term line of sight is clear to you. But still, let us understand it better with the help of a few more examples. Students, suppose Rohan is standing in the park with his friend Ansh. Now, Rohan is looking at Ansh's hair as he's just got his stylish haircut. Now, can you draw the imaginary line from Rohan's eye to Ansh's hair? Yes, my friends, this imaginary line displayed on screen is the line of sight. Now, friends, after discussing the hair, the boys started discussing what they should play. Now, they were looking at each other, so you can guess what is the line of sight from Ansh's eyes in this case. As shown, friends, the line of sight now will be a straight line from Ansh's eyes to Rohan's eyes as Ansh is looking at Rohan while discussing the games. Wow, this is interesting, isn't it? Now let us go back to Ria and understand how to write line of sight mathematically. Suppose, friends, Ria is standing at point A and the point B lies on her eye level as shown. If the balloon is at point P, then BP is the line of sight. Now, as the wind is blowing, the balloon moves from point P to Q. So, can you identify the line of sight? Yes, it's BQ. So, the term line of sight can be defined as an imaginary line drawn from the eye of an observer to the point in the object contemplated by the observer. Friends, have you ever heard the term elevation? The next term that we are going to learn is based on this term. Can you guess it? Well, it's the angle of elevation. Consider the case when Ria is watching the balloon at the point P. Can you see the horizontal line BC? The angle formed between the line of sight BP and the horizontal line BC is known as angle of elevation. Similarly, when the balloon is at Q, the angle of elevation is angle QBC. The word elevation refers to the action of being raised. So when we are talking about the angle of elevation, we are actually referring to an observer who's raising his or her head to view an object. Friends, now recall the diagram shown by the class teacher or Sohan. Observe that this is the case when the shadow is formed in the morning. Let us name it as shown. If the top of the stick is the object and the observer is at the tip of the shadow, then this is the case of elevation. Then the angle between the shadow and the ray of the sun is the angle of elevation and the top of the stick from the tip of the shadow. Now, friends, you know that the length of the stick and the length of the shadow. So you can easily find the angle of elevation using the tangent of this angle. A shadow is the base in this case and the stick is perpendicular. Therefore, tangent of the angle of elevation is length of the stick divided by the length of the shadow is equal to BC upon AB, which is 2 by 5. Friends, so far we have discussed the cases when the point being viewed is above the horizontal level. In the next session, we shall talk about the cases when the point being viewed is below the horizontal level. Till then, stay healthy and keep learning. Team Notebook wishes you